So to start, I took the square and I just took it out. So I got e minus 8, and then e minus 8. So from there, it's just a difference, not a difference of square, but just rainbows and smileys. So you just rainbows and smileys, and so you get e squared from this right there. Then since you're adding two negatives, it'll be a negative. And then you have e times 8, which is negative 8, and then negative 8e. And then here you also have negative 8e. And then negative 8 times negative 8. A negative times negative is a positive, so positive 64. So you combine that to get e squared minus 16e plus 64.
Okay, so right off the bat, I know that I'm going to be squaring t because it's t squared. So I'm going to start with something like this. And so looking at this problem, I know that whatever number is going to be next to t has to add up to 6t. It has to multiply together to equal 9. So in my head, I'm just going through a list of numbers and just trying to figure out what two numbers multiply to get 9 and add together to get 6. And so I figured out that negative 3 times negative 3 is equal to 9, and negative 3 plus negative 3 is equal to 6. So I know that this would be minus 3.
Now, it is very possible that some of you had an answer that showed t minus 3 times t minus 3. Is that equivalent?
Yes.
Yes. However, it's not the simplest form, so it would not be considered correct. Because notice how I'm multiplying t minus 3 times itself. Therefore, we have to show that it is a square binomial.
1.
So to start, I noticed that it was two different squares, as this was an even number of exponents, and this was an even number as well that could be squared down to 4. So g squared would be the square root of g to the 4th. So you get g squared minus 4 in parentheses, because negative 16 square rooted is negative 4 and positive 4. So then you also have to have g squared plus 4. And then because this has a subtraction sign and a square here, and this is also a perfect square number, it can be squared again to get g plus 2 times g minus 2. And then you just bring this down to get g plus 2 times g minus 2 times g squared plus 4.
So you have r, which is squared, so you know you're going to have something squared. And you find the number that is added to get to 8 and is multiplied to get to 16, which you can find as positive 4.
So what times what is 16, but adds to 8? So if you had written r plus 4 times r plus 4, is that correct?
Yes.
Yes, but it's not simplest form, so that's why we have to have it squared.
So for this, since L squared, you'd have to multiply L by itself. So I just started out writing it like that. And then you have to find a number that adds up to positive 3 like this, negative 18. So I knew one of the numbers had to be negative. And I know that 9 and 2 does not add up to L, whether it's positive or 3, if it's positive or negative. So I knew it had to be 6 and 3. So I had 6 right here and 3 right here, and I just had to figure out which one was the positive and which one was the negative. So I went, if negative 6, plus 3 that is, and that's negative 3, and since we're trying to get positive 3, then I knew that this had to be positive 6, that's positive 6, negative 3.
Now, the one thing I would like to show you really quick, the bonus we have for this warm-up is this. So, problems A, B, and D all have something in common. What do these 3 problems all have in common? They're not differences of squares. C is a difference of squares, but A, B, and D are. It's in your factoring checklist. Go check your factoring checklist now. Abby, what are they?
Square binomials.
They're all square binomials. And I know that because in factored form, I have a binomial that is squared. Binomial that is squared. Binomial that is squared. Now, there is a shortcut for square binomials. And that shortcut is, all right, notice how all 3 of them have a square term first. E squared, R squared, T squared, they're all square terms. Notice how the last term is also squared. 9, 16, 64, those are all perfect squares as well. But unlike a difference of squares, in expanded form, we have a linear term. All of them have a linear term. And notice how that linear term is created by having 2 of the same things. We have 2 8e's. They're negative in the first problem. For this one, when we multiply t times negative 3 and negative 3 times t, what will we get? What's negative 3 times t? Negative 3t. And so for each of these multiplications, we get negative 3t. When I add those together, I will get negative 6t. For this one right here, if we were to write it as a 2 binomials, r times 4 is a little bit louder. I know you are able to do this, so let's show some conviction on this one. What is 4 times r?
4r.
So we get 2 of them. When I add those together, I will get. So here's the shortcut. If you notice that you have 2 square terms on the ends, and the middle term is twice the square root of this term, you know it's a square binomial. On the expanding side, I could just say, oh, well, I know I'm going to have to multiply this times this, and I'm going to get 2 of them, so I have to multiply 2 times e times negative 8, and that will give me my negative 16. So there is a shortcut if you can recognize it as a square binomial. However, doing your divided rectangles will always work. Rainbows and smiley faces when you're expanding will always work as well. Your choice. That's a little shortcut for that.